Hey everybody, welcome to Control System Analysis and Design. We're going to look at Routh tables here a little bit more. We're going to look at a special case of the Routh table. So we've got a denominator here of our closed loop transfer function, which is right here. So I'm going to go ahead and create a Routh table. So s to the fifth, s to the fourth, s to the third, s squared, s1, s0. So you can all see that going on like this. And then I put these two top rows closer together because I can get those values off of here, and I spread these out for the matrix math later on. So if you want to do your formatting like that, that's the reason I do that. If you've watched any of my other videos. So s to the fifth, you're going to end up with 1, and then 3, and then 5, taking the values up here. S to the fifth, 1, and then 3, and then 5. And then down here, s to the fourth, you're going to get 2 s to the fourth, 6s squared, and then 3. And then you're going to end up, if you do your matrix math here, which is going to be equal to 1, 2, 3, 6, this row, and then this column, and this column, all over 2, negative, there, you're going to end up with this equaling 0, which is 6 minus 6, 0. Okay. So you've got a 0 in the first column. That cannot happen because you don't know if a 0 is plus or minus. I mean, a 0 has no sign. So what you have to do is you have to figure out a way to replace this 0 with some other value. I'm going to go ahead and fill in the rest of this. If you do the matrices for these, you're going to end up with 7 over 2 and 0, just to fill us out. So you see this is not a complete row of zeros, so there's not a j omega thing going on. There's just this first column that has a 0. So what you have to do in order to replace this 0 is you do a little bit of math magic and you add in an epsilon. And that wasn't a very good epsilon, I'm sorry. An epsilon. So what you think of as the epsilon is it's a very small number. Small number, like infinitely close to 0 but not quite 0. But you can give epsilon it can be positive or negative. It's positive, positive, or negative. So you treat epsilon as a number so that you can complete the Routh table, and then you go through and treat it as a positive number or a negative number in order to figure out what the sign changes are doing in your first column. So if we go ahead and finish this table out using normal matrices and all the rest of this, you'll end up with 6 epsilon minus 7 all over epsilon, and then you'll get 3 and 0, and then you'll get 42 epsilon minus 49 minus 6 epsilon squared all over 12 epsilon minus 14. That's a nasty matrix to have to do. Hopefully your instructor doesn't force you to do something like that on a test. And the rest of this is all zeros like this. A quick note here too, with zeros and Routh tables, you should always have kind of an influx of zeros. They should be growing from this side and going that side, so you have kind of a diagonal of zeros when you finish your Routh table. If you don't, you made a mistake. Just a side note there. But okay, so we have our entire first column. Since we have our first column, all the rest of this we can basically ignore, because the first column is the only thing that matters in determining the stability of the system. So what we're going to do is we're going to look at this, and we're going to assume that if E is positive, I'm going to, not E, epsilon. If epsilon is positive, what are these values going to be? So what I'm going to do is I'm going to s fifth, s4, s to the third, s squared, s1, s0. So for the first column, if E epsilon is positive, what are we going to get? Well, we're going to get a positive, then another positive, and then epsilon, we're assuming it's positive, so it's going to be positive. Then right here, epsilon is positive. We're going to get a negative right here, because if epsilon is really small, you basically have a 6 or something smaller, minus 7. Something really small, minus 7. All over a positive number, since epsilon is positive. That looks like a T, doesn't it? Epsilon. So this is going to be a negative. But then you look at this. You've got positive value minus a positive value minus a number, and epsilon is 12 minus 14. This is probably going to be a negative number, so you've got a negative number basically over a negative number. If you treat epsilon as really small, you've got a really small positive number and another really small positive number minus a negative, minus a large number. You've got a negative over a negative, so this is going to equal a positive right here. So you don't really need a value for epsilon, you just have to imagine it as something really small, but still a positive number. And then you got 3. Oh, sorry, not 3, positive. Positive. So you've got two sign changes here. You've got a positive to a negative, and then a negative to a positive. So 2 sign changes, it's going to be unstable. And that's the only reason we had to use epsilon for all this, just to get this, is because we had a 0 in the first column, and 0 does not have a sign, basically. Now, you may wonder, well, how do I know whether to use epsilon positive or epsilon negative? Well, they should be give you the same result. So we'll go ahead and do epsilon equal to a negative number here now. And what you'll end up is positive, positive, and then s cubed. Well, you've got a negative 6 now, minus a negative number, all over a negative number. So you've got negative over a negative. Or no, a positive over a negative. I apologize for that. Or no, I jumped the gun. The epsilon right here, which is going to be a negative, and then you're going to have a positive, then you're going to have a positive again, and then a positive again, and again we have 2 sign changes right here. So no matter whether E is positive or E is negative, you should have 2 sign changes for both of them, which we do. If you don't have 2 sign changes, then you made a mistake someplace and you need to go back and check your math up here or how you were evaluating E. So again, the only time you ever use E is if you have a 0 in the first column and this is not a 0 row, a row of zeros. That's the only time you ever have to use epsilon.